So it's about 20 past 2, so I think I'm going to be talking until 20 past 3, and I could talk about this for days, so I will have more material, but then we'll just see how many of you are still awake, and like how much more, well, are we going to say something else, or are we going to finish it up there? Yeah, we'll see. So anyway, Sonic Pi, I see there's already some people who know the programming language quite a bit. It is a programming language. It's designed specifically for programming music. And we've got some Ruby developers over there, and actually this is built on top of Ruby. When I first saw this, actually that's funny, it was at a hackathon that my company was organizing, and we had a lot of Raspberry Pis and a lot of Edisons, and some guy booted up Sonic Pi on the Raspberry Pi and was just messing with it a bit. And I saw that and I was like, what is that? That looks awesome. And I pushed this guy away from his chair. And I sat down there, started programming like drum beats and stuff. And that guy's sitting over there right now. But he did seem like he had a little fun with my messing around there too. So, well, enough to show up today in any case. And so I already introduced myself, so maybe this slide isn't very useful, but here you see my 3 most defining traits. And the way I make my money is at this company. I kind of mentioned them. So we have our stuff. We do virtualization, but we don't really use any of the mainstream products. Like personally, I don't even have that much experience with them because I wouldn't say this is my passion. This is something I do for a living, but I do know a lot of stuff about it. So if people want to hear about this, I can do a presentation about it too, and maybe that's a good excuse to learn one of the more mainstream projects and see how it differs from ours. One thing that might be interesting is this project that we're currently doing. We call it liquid metal, but we are probably going to, no, we are most certainly going to rename it because we couldn't trademark this name. And basically, the idea is to take physical devices and put them into a virtualized environment. Let me increase the size of this picture over here. So we have this switch over here on the table. Actually, might be a good idea to turn off the front lights because I think this isn't so well visible. すいません。ちょっとこっちのランプは消していただけませんか? Is this better? はい、ありがとうございます。So basically, we have this switch over here, which is really not a network switch at all. It is actually just your regular old Linux server. And on here we are running CentOS, and the only difference with another server is this has a whole bunch of network cards that are arranged like a switch. And then this blue box on top, that's actually a firewall, Juniper SSG5. And then with these red cables over here, every single port on the firewall is connected to a port on the switch. And the whole reason for setting this up is because we have a customer who has this firewall deployed in production. And whenever changes need to be made to the settings on that firewall, it is super scary because if they break something, they break production. And so our idea is to, inside of this switch over here, which is really just a Linux server, we are running OpenVDC and OpenVNet, and we are setting up different virtual networks, which basically copies their production network, and then they can run test cases on here, see if their changed settings will actually work like they expect. So physically, these are all connected to the same switch, but virtually, these are all in different networks, and they behave like they are in different networks with different servers connected to it. So if people are interested in this, I wouldn't mind taking this switch and this firewall and putting it in a suitcase, bringing it over here and giving a talk on that sometime. Oh yeah, one more thing I was going to say about it. The cool thing about it is everything becomes code. So the infrastructure itself, the networks, the servers, we use Terraform to write those in code. Like Terraform is this thing by HashiCorp. Let's see if I can quickly get an example over here. Scroll. Yeah, this is what code looks like. Infrastructure looks like in Terraform. Maybe we should turn off a couple more lights, shouldn't we? 申し訳ない。もう一度そっちも消していただけませんか？本当に申し訳ないです。ちょっとこっちの方かな、こっちの前に。そうですね。こうなら、これでいいと思います。ありがとうございます。Yeah, this is more visible, I think. So we would write our infrastructure like this. And this is going to call OpenVDC and OpenVNet and make this infrastructure. Then we still have this firewall over here. So we have a bunch of expect scripts that will put the new settings in there. And then we have a bunch of code that actually runs the tests. So all of this can be managed in Git. And yeah, it's pretty cool stuff. But that will be another presentation then. So let's get back to Sonic Pi then. This is Sonic Pi. It's called Pi because it was originally on the Raspberry Pi, but I'm just running it on my laptop now. You can run it on Linux, Mac, Windows, and pretty much everything. Maybe even on my Kindle, or maybe not that. And the thing is, this is a musical instrument. So, and a musical instrument, there's always a very simple way to make sound. If it's a guitar, you might pluck a string. If it's a piano, you'll push a key. If it's a trumpet, you'll blow in it. And you might not sound good or musical, but you'll make sound. This is coding, so you type play and then a number. Made a sound. This is actually the middle C. What if we give it another number? Let's say 74. It makes another sound, a higher one. Let's give it a lower number, 50. And so if there was somebody here who could hear that these sounds were not the same, that one was higher than the other, then to that person I'll say, congratulations, you are not tone deaf. And now let's keep this 50 over here. Let's say, I don't know, 65, 72. What would this sound like? What do you guys think is going to happen now? It played them all at the same time. So it didn't really sound very good either. But in music, sometimes you want to do this. Let's say 60, 64, and 67, not 77. Sounds better, doesn't it? This was a C major chord. If we lower this one by just one, yes, C minor sounds a little sadder, a little bit more melancholic. And what if we want to make a melody out of this? And we don't want to play them at the same time, so this is how you do that in programming, sleep. Now we have a little melody going on. What if we want to play them a little faster? Please wait a little less time. And now we already have a little music. It's not quite a song yet, but it's a good start. Now another thing you can do with this is samples. Samples, they are basically a little bit of pre-recorded sound. Just small little bit like here. Let's try this first one and be quiet. It's a sample. What about another one? Dark bush. That should be nice. Let's try something else. Haunted hum. And so samples. Samples are a little piece of sound, right? And sound is a wave. A wave, well, it has a duration, it has a frequency. And what if we change the rates? Like, let's go back to this first sample. It's choir. Very boring, right? But if we do this, it becomes like a little more atmospheric. Lower this number even more. You can imagine this playing in the background and maybe like putting some beats to it, some sounds over it. And what we've done here is we have made the sample longer. We've stretched it out. And so if it's a wave like this, stretching it means it's going to be like this. It's going to be longer and less frequent. So the pitch is going to be lower. And since this isn't about making sounds, this is about making music, let's try one of these samples. Might sound familiar, like drum and bass kind of loop. And of course, we want to repeat this. So you do that using a live loop. Live loops need to have a name, so foo, and oh, runtime error. Your loop didn't sleep. You might remember, well, because I just said it, if you play a bunch of things after each other, they will play at the same time. So imagine what happens in a loop when you don't put in a sleep command. Things will just play over and over and over, and your processor will melt or something like that. Or at least it will sound terrible. So let's put in a little sleep. No. The thing is, this sample has a duration, and we are sleeping for 1 second, but this sample is longer than 1 second, so we are cutting it off in the middle. So, sample duration. That's I'm going to adjust the rates of this, which means we also have to adjust the rates here. We're going to make the sample longer. I think I did this wrong, didn't I? That's better. And actually, I'm going to be honest, these examples I am stealing from Sam Aaron, the creator of Sonic Pi. And what he did in his presentation when he did this is like, you can go and rap over it, like yo, yo, yo. But he said he's not a rapper and neither am I, so I'm not going to do it. But the next thing I'm going to steal from him is speed it up. What if we do this? Negative number. And in that case, you just sleep for the regular duration again. Now it's playing backwards. So see, even when you know nothing about music and very little about programming, just by messing around with these numbers, you can already create some very fun things. Let's use another loop. And I want to put in a sleep time of 1, because 1 is easy to divide and to make beats out of. But as we saw just now, samples aren't always just a length of 1. So we have this stretch. What's the command again? Beat stretch. This is the same as the rate command, but it stretches it exactly to the length of 1 second. So. And it's a different sample as well. Okay. Got a good start. Let's take another live loop. This is going to spawn another thread, and so we can effectively play another instrument here. Let's have a little beat going. Doesn't quite sound right, does it? Let's stop that. So, what was going on here? Basically, I need to do this way. I should take care of the volume. Basically, these are two things. When I pushed play, I started this new thread over here, but this one was in the middle of playing. So these threads were not synchronized. They were like two not very skilled musicians playing out of time with each other. So what we're going to do next, we're going to tell this thread to wait for full. That's better, isn't it? And how about, now that we have a nice beat going on, we can think of putting a melody of that. So let's take the key of E4, minor pentatonics. Let's choose a note from this. I forgot to tell you guys about the release time. Release time is how long it takes for the notes to fade out. So setting this to a very low number means the note is going to be very short. And because those notes are very short, let's sleep for a very short time. Oh, and of course, synchronize. Let's make them sound a little different. Change the synthesizer that we're using. my point. So basically, what I've done here, this I've also stolen from Sam Aron's presentation, but I haven't just stolen it. So he did up to the point where he had basically these little sounds playing, and then he stopped. Then I took it up to there, and then I started changing synthesizers. Then I started changing the key and having it choose a key automatically. And basically, just like with any other instrument, this is the thing you can be doing or should be doing with Sonic Pi if you want to try it out. You take other people's work and you work on top of that. Like, for example, I also played guitar, and when I was learning some Black Sabbath songs and analyzing the solos that Tony Iommi is playing, I found a lot of licks that B.B. King uses in there, because that's what every single musician does. They hear somebody, they get inspired, they take that person's work and they build on it. And Sonic Pi is no different. I took the work of Sam Aron and I built on it. And there's a lot of work to be found, actually. If you push F11, you get this really nice tutorial written for people who have never coded before and don't know anything about music or any combination of those. And if you click on examples over here, for example, here's a very simple example. A bunch of bells with some random values. Let's maybe increase the size a little. That's the thing. How about, you might have heard of this guy, some Bach. So let's copy this and go back to Sonic Pi. That's the thing you can do if you want to. Let's go get another one. This is so big. What about over here? Oops. Meantime, let's go look for something else again. Assets, okay. Wait, should stop this first. These are all coded by Sam Aron, as the comment says, and you can tell he likes this idea of picking a note with a very short release and then sleeping for a very short amount of time. Every musician has their thing they like to do, so you can take this habit, maybe adapt it a little bit to your own, or think this sucks, I'm not going to use this in my music. Like, just, yeah, see what other people have done and then do your own thing with it. Actually, on that topic, maybe I should quickly fast forward to my last slide. Like, there are communities over here, like on Reddit and on the Sonic Pi website itself, where people are talking to each other and they are sharing their music. And so, yeah, basically where I am in my presentation right now, I might as well turn it all off and go home right now, because I think I've given you guys everything you need to know about Sonic Pi to put it up for yourself and give it a go. If you are going to stay here anyway, you are going to you are going to listen to me talk about music theory and how that can be applied to programming. But you don't have to understand that, is what I'm saying. For example, if you take these samples and you start stretching them and like making them play backwards, all kind of stuff, you can just do that over and over until you have something that sounds good. And once you have something that sounds good, call it music and you're done. Yeah?
I have a question about the samples. Can you take a sample and use it as a synth and play it at different like that? Seems like they kind of have synths and samples set up differently, but
They have it set up differently, yeah.
what's the difference? Is a synth just a simple formula, or is it they're actually a sample?
The synths actually use MIDI, if you've ever heard of that.
I know a little bit about it. MIDI.
So they're actually playing a different device, not this thing?
Right?
So I should
Just
say
sense
general
the
MIDI,
events.
where, well, maybe you obviously know more about MIDI than I do, but there is this, it's basically just this standard that says play a note, and then
Right,
you,
So you have to have a synthesizer to play, receive the MIDI event and play the note.
yeah, exactly. Actually, the MIDI synthesizers they're using is Super Collider. And then within Super Collider here, you have a bunch of synths.
So you can potentially take whatever samples you want, load them into your MIDI synthesizer.
Pretty much, yeah.
Synthesizers.
I've never tried this myself, but it must definitely be possible if we take the piano synthesizer, for example. And we play a middle C. Like, this is just a piano sample. So yeah, you can absolutely do that. So you can also load your own samples into this and then use them, well, with the sample command. So, any other immediate questions about this? No? Okay, then I'll move on.
Do they have any samples on Mozart?
I'm sorry, you had a question?
Sure. Is this, can this be tied to, well, me, I'm more familiar with the notation, music, right? So can you tie this with,
Not directly, but you can get something pretty close to it.
something pretty close to?
Let's take our Bach example over here again. Where is it? So let me just copy paste a little bit. So pattern times, and then here in this first array you write the notes, and in the second one you write the time.
Time, eh?
And if you want to, you can be like QN quarter notes equals 1, and 8 notes equals a half. Yeah, exactly. Actually, I started out doing all of this with scales and BPM, and then I realized Sonic Pi already has this built in, and we're taking away my fun. And since this is a programming language, you can do more than just make music. You can make it interface with an outside application. This is actually pretty much Ruby, although Sam Aaron says not to think about it as Ruby because the underlying implementation might change and things might break. But if you want to, for example, send an HTTP request from here or interface with MuseScore, if that's possible in any way, then yeah. So yeah, any other questions? Yeah, Bruce?
Do they have any examples of Mozart in there, or is it mostly Bach?
I think there's only one Bach example. So if you want some Mozart, you can write it. You can take the sheet music and adapt it.
Mm-hmm.
So there was one more question, I think.
Yeah, so you mentioned a super collider.
Yeah.
So it means this is like a wrapper to super collider?
Well, I don't know so much about the inner workings. I've never even used Super Collider for anything other than this, but it is definitely interfacing with it. It's taking this code and then translating it into commands to Super Collider.
So how much is it exposed from super collider? Because I'm not very familiar with that, but I use C sound.
Mm-hmm.
Then there's like chop. Easier, but super collider, which seems to be like more complicated.
Well,
right?
I think actually very little of Super Collider is exposed because I already don't really know what you're talking about, and I've been playing with this for a couple of weeks.
Create sounds.
Yeah.
So there are some like avant-garde musicians that use sound creation to create like ambient sounds,
Mhm.
electronic music. And I have heard that some of them will use these kind of programs. So I was wondering if you can access like functionality from those programs with this.
I just don't know.
Uh,
Could be possible, could not be possible. I would have to look it up.
Have you tried to connect like a MIDI piano?
No, I haven't. I don't have one actually. So. My guitar I've connected to my computer before, but I actually did a presentation about that at the last technical meeting, and in there I was just recording stuff. I don't think you can
Like
control this.
Like a sample sound, and connect like a piano. And you press the key to create your own sounds with this.
I wouldn't be surprised if Super Collider can do that, but I don't think Sonic Pi can. I think Sonic Pi is just about programming.
Oh, okay.
Yes?
But this is all open source, right? So, I mean, in theory, anybody that can read code, it's all exposed, depending on how people.
Yeah, if you want to get philosophical. It is exposed in a way that you can send commands to it, control it, but you don't have to know the inner workings of it, and I don't know those for a fact. Yes?
This Ruby code, is it just executing this like in a Ruby environment, or does it pre-process it or do something? I've never used Ruby. Is this just literally Ruby code?
Well,
Basically Ruby.
so I don't know about Sonic Pi, but Ruby in general is an interpreted code. So basically the source code gets read line by an interpreter as you're running it. And that means if you have syntax errors, for example, those will just blow up in your face at runtime. So it also means you can do stuff like meta programming, but yeah, this is all run and then at runtime being translated into like something the computer understands. I started that sentence and then thought, hey, I actually don't know exactly how many steps there are until it is machine code. But, yeah. Yes?
That was the middle window on the right.
This one?
Showing? Yes, that one.
Oh.
I noticed when you run something, then all the commands seem to be appearing
They are,
there
yeah.
one after the other, right?
For example, if you run this again. So yeah, all the synths that are being played, all the samples that are being played, are showing up here.
I believe this is being expanded into that.
Yeah, this is all being sent to Super Collider. And over here you also see how often well, these loops are looping. This is, unfortunately, I can't increase the font size here. It shows like which threads, which notes, how much time has passed since the beginning of the song.
If you stop it, does it stay there?
It does actually. Yeah, then it stays here. And the last thing says pausing Super Collider audio server.
Actually, I don't know much about the internals of this, but if you go to the GitHub page and you go to the languages in Sonic Pi,
Let's see.
it has actually a lot of stuff in it that you wouldn't expect. But it's got Ruby, but it's also got. When you click this bar, the commits bar again, and first.
Comments here, yeah.
Oh, sorry, no. Sorry, you can get a proportion of the languages.
Where is that
The
again?
color bar, sorry, the color bar, the one just below that. Yeah. Oh,
Comments? The color bar? Okay.
so see, look, it's Ruby, but it's also got closure and it's got Erlang in it.
Yeah.
I don't know why. I was really curious.
Well, the first version was closure before Ruby got that.
Also, it's just like legacy.
Oh, well, you have to be careful. This can misidentify stuff too.
Oh, really?
I have several projects that apparently have Perl in them, though I
It
never.
actually is going.
Is this actually Erlang?
No, I don't.
This
This
is
is.
Perl,
This is.
right?
This looks like Erlang,
So
yeah.
the functional list of other things. Maybe somebody wrote a shell around the thing to drive it from this.
What file is this?
What is?
App server Erlang osc.crl.
I don't know what they're for, but. Yeah, I was curious why you would have so many different languages in your project.
Um,
Ruby's kind of obvious, but the rest.
Battle between the programmers.
No, I would
No, I'm
know.
doing mine Erlang.
You'd have to ask Sam Aaron. Maybe you can hit him up on Twitter or something.
That's 248 contributors, I
Mm.
think.
Well, I think that maybe I'm going to move on now. So, yeah, actually, I wanted to show a couple of projects that use music programming in the real world. They're definitely not using Sonic Pi, but they're doing some cool stuff with music and programming. For example, Killer Instinct. This is a fighting game, a really cool one. I played the crap out of it on my Super Nintendo back in the day. This is actually a new one. Like, you had Killer Instinct on the Super Nintendo, then Killer Instinct Gold on the Nintendo 64, and then nothing happened for a long time until the current generation of consoles. When the Xbox One released, they made a new Killer Instinct game. And this one does some really cool things with the music. Let's have a listen. So, oh yeah, actually, maybe I'll say one more thing about it. You see over here how I have some random stuff going on. I choose a certain key to play in, I choose a random note from the scale to play. And in a game like Killer Instinct, you can choose to react to stuff that are not random, like for example, what the players are doing, and that's what's going on here.
Ready, fight!
He basically repeats this process a couple of times in this video, so I'm going to fast forward and show off what an actual fight in this game looks like, or sounds like, rather. Then I'm going to fast forward one more time to the ending of the fight, when somebody executes an ultra combo. And Killer Instinct and ultra combo, that's basically, well, a very long and flashy combo to finish off your opponent. And they did some pretty fun stuff with them.
I'm afraid your path ends here. Supreme victory!
I love this game. But yeah, this is just some of the really cool stuff you can do with music and programming. Like, if you have a bunch of instruments that are playing in the same key and to the same chord progression, no matter what they're playing, it'll fit together. And with programming, you can basically look at what the players are doing and react accordingly. There's actually one more game that does this. This is one of my favorite games of all time. It's called Red Dead Redemption.
rode in the gang. They left me to die after I'd been shot.
So, unfortunately, the dynamic music is not shown off in this game, but I actually lent it to one of my friends at one point, and when he gave it back to me, he told me about these amazing moments, like the sun was up in the sky, it was just past noon, and he rode his horse across the border into Mexico for the first time, and there was this one guitar chord, like just one that played, and it completely set the mood. It was a defining moment of the game for him, and I thought to myself, I don't remember that moment. I would remember something like this. What's going on? And then a few months later, I was watching this YouTube trivia channel called Did You Know Gaming, and they were talking about Red Dead Redemption and how they do the same thing that Killer Instinct does. And the music is all written in the same key. It's all like at the same BPM, or at least with transitional parts in between them. And yeah, the music reacts to what the player was doing. So that moment of riding into Mexico with that guitar chord, it existed in my friend's playthrough, but not in mine. I think that kind of stuff is pretty damn awesome.
Cannot be conventionally civilized. Maybe you live in a different America than we.
Cut you up, piece by piece.
Great game. Unfortunately, it's not on PC, but they are building a second one right now for PS4. This one's on PS3 and Xbox 360. Third one, yeah, Red Dead Revolver was first. Very good. So, anybody want to hear me talk about music theory? Like, actually, at first I was going to avoid this topic because there are a lot of people who are like, music theory, that's boring, that's for in school and whatever. But then I watched Sam Aaron's TED Talk about Sonic Pi to prepare my own presentation. And he was saying how he goes to schools, he gives these talks about Sonic Pi, and people come up to him, and even teachers, they come up to him and they're like, I just don't get technology. And they say it with a proud face. And how it bothered him, because like, why close the door on that for yourself while really, like, you could learn that, and even if you don't become like a major professional at it, like, why would you be proud of not knowing it? And he compared it to reading, like, you shouldn't be proud of not reading, but anyway, I often feel the same way about music theory, like other musicians as well. Sometimes they tell me like, music theory, that's boring, I don't want to do that. But for me personally, I haven't been playing the guitar for very long, actually. Like, I didn't have any music around me at all until I was like 20. I was just playing games, and music was something that played in the background. My parents were not interested in music, my friends weren't. And only when I was around 20, I discovered heavy metal, and that was awesome. And then that was so awesome, it made me want to play the guitar. And then I played the guitar for a while, then I stopped, and then I came to Japan, lived in Japan without even having a guitar for a while. And then this guy told me, come on, man, you got to bring your guitar, and I play the drums, let's go, let's play. I did it while thinking, am I really going to do that? But okay, I started playing with this guy. He also knew very little about the drums, but it was fun. Then at one point he tells me, I want to write something of our own, after we had been doing this for a while. Like, I thought, okay, I've never done this before, you've never done this before, but sure, let's do it. And so, yeah, I studied some music theory and figured out how all of this works. And it was all so simple. I was surprised. And just by learning a couple very basic concepts, even somebody like me was able to write a song. And I've written a couple of songs now, and I've performed them in front of people with my band. So, and I'm not going to be a professional musician either. So, yeah, basically, I think music theory is pretty cool. It has applications in programming as well. And actually, when I kicked our good friend over there away from his chair to do Sonic Pi, that's what I wanted to do. I already knew music theory by then, and I wanted to apply it in programming. And so I've got a couple of misconceptions to debunk at first. The first one is the one I hear most often, where music theory is making all these rules, and music shouldn't be about rules. You should be free to do whatever you want. And that is such utter bullshit. Like, music theory isn't making any rules. It is merely describing what is going on. Like, compare it to the laws of physics. So we have all these mathematics, like describing gravity, electromagnetism, and like time and the universe around us, basically. But the universe doesn't care. Like the planets were spinning around the stars long before we were on this planet. Never mind making those mathematic formulas we made. So music theory is similar. It's basically people have been making music. We feel emotion through music. And then there's some other people who start looking at it and think, okay, what exact combination of sounds incurs this emotion? And then they wrote down what they found, like they gave it a name, wrote it down for other people to learn. And that's music theory. Very hard to learn? No, it's just very simple. Like, how much time have I got left? Well, okay, I see my plan was to end at 20 past 3, so about 10 minutes. Okay, I don't have enough time in 10 minutes to tell you a whole lot, but still I can tell you some of these concepts and they are going to be useful. Requires talent. I just told you I don't have any. I was just some guy who had never even been around music, and when I first picked up a guitar, like, oh, I'm glad you didn't hear it. Whether it's boring, that is up to you. But to me, like writing my own songs like that, and I'm reading about which sounds describe which emotion and really make you feel it, then if I have an emotion in myself and I want to express it, this is giving me the tools to do so. And at least in my opinion, that's not very boring. And I actually did go to music school for a very short time when I was about 7. It was basically one Saturday morning, my mom told me, hey, in half an hour, we're taking you to music school. And I was like, what? And so they took me to music school, no music around me, never interested in it at all. And I hated it. She just like made me like write all these notes. They made me play the xylophone a bit, which I did with not the least sense of rhythm. I only learned how to keep time in 2014, 15. Eventually, my father started helping me with my homework because I was always failing everything, but he didn't know music either. And it didn't take long for my parents to figure out this wasn't going anywhere. So they tried, but they soon allowed me to quit, and I quit immediately. But there's one thing that they told me in music theory, and well, in music school, I mean, those were the minor pentatonics. I had to memorize the minor pentatonics in F. And so I did. I wrote them down on the test.
This is what made you a guitar player? Oh,
no, I immediately forgot about them right after the test. Like, I became a guitar player because of Iron Maiden. But
That's what I'm saying.
yeah, that's what I'm leading up to as well, actually. So basically, I wrote those pentatonics on the test and immediately forgot about them because that's the only purpose I knew about for the pentatonics, just to write them on a test. And then fast forward about 15 years, I'm in college. I'm supposed to be studying, but I'm not. I'm procrastinating. I go to a music store, check out the instruments, and I meet this lovely lady named Sophie, and she's doing this. And so I talked to her and I'm like, wow, that sounded great. When I play the guitar, it sounds stupid. It's like, how did you do that? And she tells me, oh, that's minor pentatonics. Imagine my reaction this time compared to when I was in school. And yeah, so she also tells me that she's a private teacher. So we exchange phone numbers and I start learning guitar from her. And unfortunately, I could only do that for 1 month. And after that, I had to move to another country. But I did end up buying this guitar from her, the one that she's using in the video, just last year, actually. It's in my home in Japan now. But so, the minor pentatonics. This is what they had me learn in school, the row on the bottom. And actually, I've learned from Sophie how to play the guitar, how to use the pentatonics. And I can do it in any of these keys. And I still don't know the contents of any of these arrays over here. And how does that work? Because there's a way more efficient way of thinking about them, which they didn't teach me in school. So maybe some smart programmers have already seen a relation over here. we've got a list of notes over here. The space in between them is 1 semitone each. And pentatonics in C, let's see, E flat is the next one. See, 1, 2, 3. What about G? B flat, G, 1, 2, 3. These are the minor pentatonics. Now it's starting to look a little nicer. This we can remember without like, memorizing every key for every scale. But this is still pretty dirty code. That's better. This is all there is to it, to a scale like that. And actually, the distance between notes like this, we call intervals. And they all have names. And when it comes to music theory, to understand harmony, to understand like which notes sound good with which other notes and make you feel certain things, this is where it's at. You don't have to remember do, re, mi, because those are just absolute values.
Do, re, mi.
It is, but just called something else. And if you play in another key than C,
It's still do, re, mi.
It's still in there, but they're not in the same places anymore.
Yeah, the whole point of do, re, mi is do can be anything. It doesn't have to be C. You make do A, now you're in different.
Well, you can do that as well, but
that's the point of it. That's the primary purpose of do re mi, is to say I'm going to switch to A, and now A becomes do.
I have heard of that once on Wikipedia. I've never seen a musician or heard a musician do that. When they talk about do re mi, in my experience, they're always talking about the absolute values, and when they don't, then they'll use this. That's my experience, at least.
That's one of the big differences between the piano and the guitar. With the guitar, you can move it around on the keyboard and
Yes.
it stays the same. On the piano, you have those black keys and they're not moving anywhere.
Yep. Actually, I watched another TED Talk while preparing for this who called the piano keyboard design fault, which I'm inclined to agree with, actually. On a guitar, you don't have this. On a guitar, you have a fretboard, and every fret is a semitone. You have these 12 notes. And these are the pentatonics in there. So if you remember this, you can play them in any key as long as you don't have an annoying keyboard like piano. But in Sonic Pi, all you have to do is write this. And also these intervals, they no matter what key you play in, they will kind of like a perfect fifth, for example, will always sound like a perfect fifth. If you're in the key of C, then, well, a C will sound like the root. If you're in a different key where C is another one of these, then it will no longer sound like the roots, but these will always be the same no matter what key you are in. This might start to sound a little complicated. I'm quickly going to go through a couple of other scales. Here's the minor scale, the major scale, Phrygian mode, Mixolydian mode. And these are all difficult words, but the point I'm making here, all of them are just a subset of these 12 intervals. And I remember Michael talking about Mixolydian and Locrian and some other stuff at an Omikai, and people around him going like, what the hell are you saying? And well, now at least everybody in this room knows what he was saying. He was just talking about these intervals. And okay, so you know these intervals, these scales, then what good does it do you when you're writing music? When I was writing that first song for my band, the band was called The Sandman because we were playing Enter Sandman by Metallica so much. And so I thought, what should a song by The Sandman sound like? So I thought sand, deserts, Middle East, Aladdin, genies. That's the kind of stuff we should sound like. And then I thought, oh, wait a moment, Metallica, wherever I may roam, you see I have it queued up. That. I thought that's what I want our first song to sound like. So I went to Google and I looked it up. How to sound like that. I found this. Let's fast forward this video a little bit.
How harmonic minor is constructed this way. It's 1, 2, flat 3, 4, 5, flat 6, 7, and 1, or if you prefer traditional intervals, that's root, major second, minor third, perfect fourth, perfect fifth, minor sixth, and major seventh intervals. So in the key of A harmonic minor would sound like this.
Let's listen to that again.
No. Harmonic minor is constructed this way. It's 1, 2, flat 3, 4, 5, flat 6, 7, and 1, or if you prefer traditional intervals, that's root, major second, minor third, perfect fourth, perfect fifth, minor sixth, and major seventh intervals. So
This is what he said.
Oh, minor scale.
Yeah, and so I thought like, okay, this basically gives me the tool to sound the way I wanted to sound. And then there's, I already knew a couple of other scales, for example, the natural minor scale. Anybody noticing something? There is only one note that's different. And the natural minor, like this is kind of a bread and butter scale, like it's used all the time, all of you have heard it, like constantly without even knowing it. And only one note makes it sound so different. Like this blew my mind. So I opened up TLUG's guitar. Well, actually, first I did it on my real guitar. See on the bottom here, there's a guitar fretboard. I've done a presentation about this software too, which I could always do again. There's interest. I knew I was going to be in E, and I wanted the harmonic minor scale. So now down here are all the notes on my guitar neck that I knew I could use that were in the scale. And I knew the difference was the major seventh, which is just one semitone below the octave. And the octave is the same as the root, just higher. So I knew I have an E over here. This is probably a little small to see, but take my word for it, this is an E. And then one semitone lower, there's a D sharp. That is my major seventh. Here too, E, and well, there's D sharp. So as long as I accentuate that note, I'm going to sound like the guy who was just playing. And this is what I came up with. So, yeah, just simple music theory, just a couple of notes to use, and suddenly you have the sound that you wanted to reach. And all these different scales that I was going through here, they all have their specific sounds. It's just such a nice playground to go have fun with and discover. And for example, if we go back into Sonic Pi, here we were using the minor pentatonic. How about we change that to harmonic minor? Can you hear like the kind of hints in there? I'll change it to natural minor. And that's the fun to be had with music theory. So this is about the time where I said I would cut it off. I was planning to say a little bit more, but I didn't really think about time for the questions in between. So what shall we do? What do you think, Edward?
Well, yeah, if you want to question.
Okay.
Yeah. Have a break.
So yeah, let me just put on my end slide. I was actually going to talk about rhythm, going to talk about some blues as well, but maybe for another presentation then, or if we have some time way at the end. But any questions? I think maybe the questions were already answered in the middle.
Right then,
Yeah. Oh, and if you want to check out some of the stuff I've been writing to prepare for this, I've got a little repository over here. I actually made a rendition of Seven Nation Army in Sonic Pi. Let me just real quickly put that up. through, and then we're done. We have the drums down here, putting in these flashes. Guitar chords coming in using this synth. And then another build up. And we're done.
Where did you define the build-up?
Build up?
Is it a function?
It is a function indeed. I was hoping to analyze this code and step through it, but maybe next time. So basically you define a function like this, then call it somewhere else. This get function over here, that's a thread safe way to store your variables and share them across your threads. And I have a more complicated function to play the bass line because I wanted to be able to take the same line and basically add in different intervals, change the key, and like add in more chord tones on the fly.
Just one question. Is
Yeah.
there a restriction on how many sounds or instruments you can play at the same time?
If there is, I haven't hit it yet.
So there you're passing in the interval you want to use, and like
Yes.
line 17.
So, for example, see, for example, here, this is the main bass line. So I play the root everywhere, and then sometimes I add an interval to it. So I make the note higher. So basically, this goes like dun, 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 dun. See how it goes down here?
One question.
Yeah.
The times you were saying before, and you said you had to sleep money to the second.
Yeah.
The times always in seconds, or could you actually do something when you define it?
Very good question.
For example,
Right here. You define the beats per minute. This is another thing where Sam Aaron took away my fun because one of the first things I wanted to do when I saw this was make programmable BPM. And so I was dividing my sleep times and doing all that stuff. And then after I had built it all, I read in the documentation, this is just a simple use BPM command.
So the parameter to sleep is
In beats, yeah. Quarter notes.
Because if it was in seconds, that would be really hard to scale if you wanted to screw it.
Yeah. And actually, I have a question for Curt. So you said about how do re mi is relative, just like the intervals
Yes.
I mentioned. And what about CDE? That isn't relative. That isn't.
C will depend on what you've defined do to be. So if you've decided do is C, then do is C. If you've decided that do is A, then C will be me.
Okay, then I stand by my previous statements that I haven't really met many musicians who do that. Yeah.
I think there's a thing called fixed load, fixed, and then a removal load. It depends on if you go 4440 hertz frequency, it's an A, and if
Well,
you
it's
switch to a
normally used by
different,
singers.
yeah, but I mean,
who are always-
I think both were correct. But I'm not very familiar with that part of music theory. I haven't studied that one, but there's this thing that you can sing like the actual note that we assign, like do, re, mi, and then if you switch to a different scale, and you sing based on the intervals, then you can just call it do as well.
Right.
But it doesn't mean that he was wrong or. I think both of you were
Well,
correct in that sense. It's depending on which system
Yeah, it
you're
would be
using.
very strange to say that do always has to be C, because then using just do, re, mi without whatever special words they've come up with for sharps and flats, you could not actually sing in any other key. Because if you're in the key of A, The third note of the scale is a C sharp. So what would you be singing, like La, Ti, Do sharp?
Yeah, well, actually, I don't really understand yet why they've defined those sharp and flat things at all. Why not just have 1 to 12? But
Piano keyboard.
so basically, all based on that design fault.
Yeah.
Yeah.
Well, technically organ keyboards. It's
And that, and
long
the
period
line,
piano.
the line one up there,
Yeah.
you set your basic
My
tonic
key,
note there. The key at E3, right?
I set it in E3 now. I can set it to C4 as well or anything. E3. You can set it while it's playing. But this is not built into Sonic Pi. This set function is just something to set a thread safe variable. So I call it root. Actually, usually I call it key. This time I call it root. And then I'm getting it everywhere. And I noticed this is actually not completely thread safe when I was programming some blues. So this code is just a little older, like a day older. But nowadays I tend to get it and store it in a variable and then only change it when I'm sure that I need to change it right now, so it doesn't happen in the middle of a bar or something. Okay, so guess maybe it's time to wrap up. I hope this was at least a bit interesting, and if you know another community that might like this talk, I would love to do it again because it's been a lot of fun putting this together, and like I have a lot more material that I could talk about, or if it needs to be shorter, I could also just do the demonstration I did in the beginning and finish it there without talking about theory at all. So yeah, let me know if anybody wants this talk done again. And also if you do something in Sonic Pi, please send it to me. Like put it on the TLUG mail list or something. I'd love to see what you guys come up with. Okay, thank you.
I'll just try and sort this out.
Oh, yeah. Everyone's attention just for a second. Just for a second while everyone's trying to queue up the next thing. This is sort of my penance for having made a suggestion, is that I actually get to stand up here and carry it out. But I was thinking that the way things have worked before for presentations is that usually somebody will say, before it would be, Alberto or, and now recently Edward would say, does anybody have anything they want to talk about? And then people would volunteer, which is cool. But in order to sort of like see the pipeline, so to speak, I was thinking, my suggestion was, why don't we see of the people that are in the room, if there's anybody that somebody actually, in any subject, Linux or, the periphery of Linux, that people want to hear about. And then that way, if we have a short list of things that people are actually maybe interested in, and some bunch of people say, oh yeah, I'd be interested in that, then we might be able to find somebody that knows a little bit about it that could then research a little bit into it and come in and bring a talk that they might not have thought of otherwise. So I just wanted to start. I've also been keeping a list while people were introducing. I've got a list of 3 people who've already said they want to talk about something, which is good. So we're starting to see the pipeline. But is there anything particularly that, like for example, the example I threw in, which I'll throw this one in the hat right now, is I run an Asterisk network. I run an Asterisk system for my home phone. And the thing is, that's kind of, long in the tooth these days, and as far as I know, not really even supported anymore. And I would like to, I don't think so, it might be, but at the very least, it's not easy to find information on it anymore. So I'm thinking there's other better solutions, but I haven't really had the time to research into it. If anybody actually say, well, hey, I'm using such and such a thing, why aren't you using this? I'd say, hey, come on, bring in a talk, talk to me about it. Let's learn something about it. If nobody, of course, knows anything about it, one of these days I'm going to have to migrate my system to something else. Anyway, I can bring it in and talk about it once I do that.
Benjamin can help with that topic.
Yeah.
I met Benjamin Not here today.
No, no.
I met him like 15 years ago. Called me up and somebody had given him my name and he said, I want to tell you about this. And he was talking about asterisk and it was like, oh, that's it. So, but I think he might be using FreeSwitch.
All right, well, I'll contact you to see if you can tell me which Benjamin, because I don't think I know him. And,
The chef.
well, there you go. That doesn't really help.
The guy who made, for the last, dinner.
The modular too.
Okay. All right.
I think I have a picture if it's needed.
Yeah, pictures really help.
No one
You know, we ought to
can.
we ought to all bring in little name badges.
I'd be very interested in that too.
Would you? Yeah, I would be. So is there anything else that some of the people would actually be interested in that they would like to hear us talk about, but not necessarily, that they don't necessarily know anything about? And don't worry, it's not going to be that, as soon as you it won't be like my situation where as soon as you make the suggestion, you're going to get somebody go, okay, you get to talk about it then.
Does anybody want to do a talk about PC board design? Building your own little computer?
Yeah, that'd be good.
Huh?
I'd love to hear one.
Yeah, no, that's what I'm saying.
Wow.
I'd love to hear one. Like building one little ARM processor, it's kind of like building your own Raspberry Pi type thing.
Yeah, and as you get ready for that, there's this website and like a Chrome app called draw.io. Anybody know that? The hardware? Wow, that's pretty.
So I'm wondering, if
pretty
there
neat.
be like a bunch of free or open source stuff?
Yes.
Well, the way to do it, they'll spend $10,000 or something.
Yeah.
How do you do it? What are all companies you use, vendors, tools?
There you go. Got it written down. I can't answer that. I can't answer the question, but that's one of the potential topics. And of course, what you can probably expect is that at some point, one of the, when it comes time for everyone to say, hey, who's going to talk about stuff? We got this open slot. We don't have anybody, then I'm going to trot this list of topics out and say, any of you guys know anything about these things that we've already identified? Somebody wants to hear about. Is there anybody besides Justin and myself that's interested in Harvard Design Language, for example?
Yeah.
One between the two of us, a tag team or something. What else? Anything?
I want to know about the programming. Maybe write one source and then you compile for Windows and compile for Linux.
Okay, portability, basically is what they call it. You want to hear something about that, or you want to talk about it.
I want to hear about it.
You want to hear about it. So I thought you said talk. I was going to ask about it.
So what languages are available? What development environments are available? Is .NET Core worth using, for example?
Yeah, that's a good question.
Should I be using Ready Everything and Visual Basic?
Yeah, I want to hear about Global Sumo.
After right now.
Remove this.
Well, that we don't have to put on the list because you're going to hear about that apparently.
I'd be interested in learning something about the future of video on the internet. YouTube's been censoring recently. Facebook, Twitter, they're shadow banning people, kicking them off, and giving them strikes. And so there's some websites out there. One of them is called BitChute that seems to be taking off. A lot of them like come and then go, but this one seems to have some legs. It uses a technology called WebTorrent, which I think is just like BitTorrent on JavaScript. And I'm interested in that. Has anybody ever heard of WebTorrent? WebTorrent.io is coming, and the kid behind it, I think he sold his first company to Yahoo, and then he's off on his own now. He's self-funded. He's one of these people who says, okay, I'm on my own. And he looks like he could be making a lot of money at a big company, but he's doing this because his heart's into it. And it's been picked up by quite a few websites. It's not much of a change to the BitTorrent protocol at all. You just add one thing. You guys probably heard of transmission, right? It kind of comes bundled. Well, I don't think transmission supports this, but some others do. So it's one of these deals where it's going to fight censorship, which I'm
Yeah. Hoping that you talk
Well, I mean,
on a
I-
number of different topics
Here.
over the course of the coming meetings, yeah.
Yeah, I just want to throw it out there for anyone who wants to check it out.
I mean, this is kind of mundane, but I want to switch from X11 to Wayland. I want somebody to explain to me what
Switch-
Wayland.
Wayland?
Window manager.
Oh,
Oh,
I'd say,
yeah.
graphical.
It seems like it's finally got to the stage where it's kind of stable, I guess. I don't know, like, I don't something big. And so, but I'm tired of X. I want to switch over. And I'm looking at, so i3 has a version. So, but I want somebody to tell me it's okay and I can do it. I think you can do it. Yeah, I know. I'm gonna try anyway, but, yeah.
Maybe you
We're
can
looking
target
forward to
and
your
then
report.
talk about
Yeah, I know. It's gonna come back around. I knew this was.
Yeah, well, yeah. Sometimes
I encourage you
that
to
happens.
do it, I'm sure it'll be fine. Let me know how it goes.
Yeah, I think window managers and desktop environments, I mean, that'd be interesting to see what people use and why they use it.
Yeah, that would be something that would be good for maybe a series of short talks.
Yeah, launching
Time
talks
where-
or something.
Where somebody who has their favorite window manager, because I'm sure, I mean, out of this many people in the room, I'm sure if we took a poll, there's probably about 12 different window managers actually being commonly used by people. And so, yeah, but you space it out over one per meeting. That way we can't really flame each other because we'll forget what the other ones were by the time the next meeting comes
This
around.
was interesting. Just show how you are working.
How you working and how you use it and stuff like that. Yeah, that'd be kind of cool. I'd be interested in that.
Another topic might be something like, have anybody heard of Streisand? It's
Streisand?
like a.
You mean the singer?
Barbara Streisand. It's named after Barbara Streisand. I guess she tried to stop reporters from, journalists from filming her house or something. Google Maps. So it's called the Streisand effect or whatever. Anyway, it's this thing you can install on DigitalOcean or Linode. It's an automated install of like 3 or 4 or 5 different like VPN technologies. I think Tor's in there because WireGuard, OpenVPN, Shadow Socks, I guess it's called, Jim. Is that right?
Yes.
And whatever, as other different types of tunnelings. And you just set it up and then you just start routing your traffic. I like it. It's the first one, when I went through the settings, I was like, oh, what's going on? You know, it's like, so I chose some defaults that you have to pick like how many tunnels you want, 5 OpenVPN clients, 5 WireGuard clients. And so the second time I went through, I was more careful about choosing things. And the one thing I have is, and it's like, I didn't have my domain set up. It's actually got, what's that called? The HTTPS thing, like a project by EFF that just installs like certificates for you. Yeah, it's got Let's Encrypt built in. It's pretty cool. So it's on GitHub, very popular. It's called Streisand. So if somebody wants to play with that, and then I'd happily like talk about what I use. And I'm using it right now because I've got some things that call into that, and then I connect to that. So I'm using it for my own cloud.
You know what I'm thinking? This is kind of a crazy idea. Is it just like magazines have like regular columns where somebody like does a column every issue of the magazine? Ken ought to have his little corner. Something on the topic of privacy at each of the regular meetings. Just something. It wouldn't have to be long. Just that's what I just to
But
suggest.
you already know my name, so.
So it's not very private anymore.
Actually,
Yeah, but you know mine
okay,
too. So
I guess.
there you go.
I
Well,
used
anyway,
to have a column 20 years ago called Ken's Corner, believe it or not, in the Tokyo PC Users Group.
Really?
Newsletter.
Time to revive it then.
Yeah.
Yeah.
I didn't name it.
This would be a live version. You want to?
Yeah, I just want to mention about a project that I'm kind of working on. I'm trying to learn more about EMF, RF, and microwave radiation and how to protect yourself from it. So every time you pick up your iPhone and you talk on it, every time it gets connected, the EMF radiation just spikes. And so, like a number of people, like McCain always used to use a cell phone, and now he's got really bad cancer right behind his ear now and stuff. I have a feeling that it's from the using a cell phone and the cell phone radiation. It doesn't agree, but oh well.
Well,
Anyway.
I mean, take all the people who've ever used cell phones and all the ones who've ever had cancer right behind their ear
Right.
all over the world. And yeah, you might find that if you just by chance, you'd expect to find a whole bunch of people just randomly gone.
Bruce, I can put you in touch with somebody who studied it quite.
Okay.
He's not in Japan.
Oh, that'd be cool.
It's non-ionizing radiation. It doesn't matter
We'll save it for the presentation.
how much.
On the other hand, like amateur radio people are really kind of weird. You think that's watch it.
Another suggestion?
Not directed at anyone.
But another suggestion for the list, or this is pretty much?
Yeah.
Okay.
I'm in the data recovery business. I have a job here that has like 140 MPEG video files on it. They're all deleted. So I want to reconstruct them all. But, well, I have an idea how to do it by hand, but that's going to take me weeks to do. So is there any utility that will do it for me? All right, to take a couple of days to calculate it, but should look. I know the start of the video file, and then I wanted to gather all the data, the fragments of the video file, and put them all back together. And also, Curt, in the end, give me the video file. Also, tell me which fragments it used. I have a need for that.
Wow. Your need is more immediate than probably the next meeting.
I get these kinds of jobs pretty often.
But for forensic
Speeding
file,
work,
forensic
too.
file reconstruction, if anybody knew about that, we could have that as a topic. Well, anyway,
One more quick thing, we mentioned Let's Encrypt, but that might be good. I mean, it's pretty easy to use, but maybe somebody could show us
That
how
makes
to
a
actually
nice
use it.
presentation, how to use it.
Yeah.
It might be too simple. Depends on the resolution.
Yeah. That's, yeah.
but getting the general, you picking one distribution
Yeah, I
and getting the
think it's been
general
added
tips
to
would
quite
probably
a few
help.
different other projects, like another VPN project called Tunnel. They've added it in there recently. They've made it really easy.
It might be too easy now, but.
No.
Yeah,
People
there's enough in it
take
that you
turns
could
saying,
talk about.
You know, how they've done it. There's different.
Yeah, I'm
methods.
ready to go if you.
Okay.
If you
Well,
were
anyway.
just treading waterway.
I've got a huge list now. Of course, the trick will be at some point is maybe next meeting or sometime over the list or something like that, to produce the list and say, out of these things, who actually knows something about it.
And I mentioned it during my presentation, but I could also talk about virtualization stuff that we do at my company.
That's true.
Oh, I have you. Yeah, that's right. I was going to talk to you. I during the introductions, there was 3 people actually that mentioned having stuff that they really would want to talk about, and that's the flip side of this. So matching them up so that we can somehow fill the pipe with enough people to present each time.
And I could do more music-related stuff as well, like TLUG's guitar, this thing, well, I showed it up just a little bit, that I used to learn songs on guitar all the time.
Oh yeah.
I've presented this before one time, but it's a couple of years ago, and there's a lot of new faces since then, so.
Sure. Yeah, that'd be fun. That'd be cool. All right. Anyway, we're ready to go, so I'm going to
Yeah, all right.
take my list and step down.
Yeah, basically, there's sort of, all right, now maybe I'll grab, I should, as part of the of class in Tokyo Hackerspace, I've been building a robot sumo, and does anyone know what it is? Like robot sumo is?
I think it's robots bumping into each other, pushing each other out
Yeah.
of the ring, am I right?
Yeah, it's basically.
Okay.
Here's just someone else's YouTube video just to give a basic idea. I haven't actually made really a presentation, but this is a sort of thing. But yeah, so yeah. But it's an interesting robot project because it's not very complicated. It can involve some mechanical movement with motors, and and sensors. So.
I assume the media is not accelerated, speed up?
So no, it's not. Yeah, they're pretty fast. This is a finals, I think, on for one of these robot competitions. We're just doing it as part of this lesson. So it'll basically be the people doing the lessons. I think we've got about 4 competitors in ours, so it won't be quite as competitive. But yeah, that's kind of basically the sort of robot sumo that talk about. All right.
I would put machine guns on mine.
Well, that's the thing. As part of the robot sumo rules. Sorry. Yeah, spinning.
So he's searching for the other car.
Yeah. Basically, these are completely autonomous. They're not remote controlled or anything. You have to put them in the ring, depending on how on the rules. Like for ours, we actually have an IR code that's sent, and as soon as your robot receives that, it can start. But they're completely autonomous. They have to find the other robot and then push it out of the rink. And generally, with the size constraint we've got, it's half a kilo in weight and 10 centimeters by 10 centimeters square, but any height that you want. So yeah, if I was hoping actually to have mine in a workable state by today, but this is sort of the bits of mine that, yeah, it's a 10 centimeter by 10 centimeter block, and motor control. So you got some motors and a motor controller, and we're using these ultrasonic sensors, and it's all sort of hooked up to. I'm using a little Arduino. So that's basically, it's a microcontroller, standard Arduino microcontroller. But the other thing you need sensors for is to detect if you're being pushed out of the rink, or if you've actually ran right up to the edge of the rink so that you don't run out of the rink. We also have some color sensors or whatever, so little lead-based sensors we're using. These little sensors that we hook up. That's most of what I was going to say.
How much do you invest into one of these?
Well, it's kind of up to you. With mine, I tried to make it out of as cheap components as I could. You can buy, there are a lot of sort of robot components you can buy, and you can actually buy kits that are pretty much, you could use them as a robot sumo. I used a pre-built gearbox. I didn't try and make that. I had to, with this one, I made sort of custom tires based out of some existing tires. I actually tried making my own tires, but I really need a metalworking lathe to do it. I initially made some, but they were slightly off center, and so sort of bounce around too much. And with the size of engines on this, it actually has a lot of torque and a lot of speed. So without having well-balanced tires, it sort of bounces rather than drives. But I had to make some fixtures to attach the or some brass fixtures basically to attach the tires to the gearbox, which is using sort of a hex-based pin. But anyway, yeah, it's also for this, because of the size I was looking at, I ended up making a custom battery case. This one, when it's all set out, it's going to take 8 AA cells, so fairly heavy. I weighed it, and it just comes in just under half a kilo. And
What kind of Arduino processor do you have on
it's a
ADR?
sorry.
ADR.
Atmel. Well, so Atmel Mega 32U4, 5 volt, 60 megahertz. It's an Arduino Micro. So. But, yeah. But,
The 18 by 32U4 is very similar to the standard one they use, except it's got all. So that's what it's
sorry.
called in our team.
Oops.
It's
USB used, I think?
yeah, it's used to upload the your sketches from your computer to the
I thought the other ones do it just over serial.
They have a USB to serial converter, and then you talk to it over the serial port on the chip.
Yeah. I mean, you go either way. I think that I thought it was just easier because I wasn't going to make more than one of them, so having it built in. But yeah, and yeah, this is actually basically just the motors and a battery pack attached to it. When it's actually running, like it'll obviously run through the motor controller instead of directly just attaching the batteries. Anyway, this is it going with 2 cells. It's when it's set up properly, it's going to be running on 4 cells in 2 lots of 4 cells in parallel. Anyway,
What's
I
the
guess
strategy for this? Is it just
oh well,
like
this doesn't actually have anything except the motors and the battery pack attached.
Ultimately, like in general, what
Well, this with the motors is actually quite fast. So what I'm going to do is it's just going to spin around until it sees the other robot and then ram it. I've one of the other ones too is I was sort of working on polycarbonate sort of shielding for the front because the sensor's on the front, and it's also because of the sort of open design for this. I'm kind of worried. I mean, it's probably not realistic, but maybe it damage the batteries or something, or knock them out or something like that. So I've got a mil thick polycarbonate shielding. I'm just going to try and melt and form around it.
Are you allowed to have your robot generate smoke?
You're not allowed to have it generate anything to interfere with the sensors of the other robots.
So
yeah,
basically
someone actually did
radiation
do,
either,
like they came up with like a foam one that actually absorbed the ultrasonics so that it wasn't actually, so it was going around and couldn't see the other robot. And so they changed the rules.
Oh.
Yeah.
That's a good idea.
The other one too is there's rules about the tires, because I think someone basically made them, like had some sort of glue or something that they'd worked out how to put on it so that you basically pretty much bonded itself to the ring when it was driving around. So with the tires, you got to push a piece of paper to it, and if it doesn't drop off within a second, then the tires are disqualified. But yeah, it's kind of an interesting project, this Robot Sumo, because it's fairly simple, so that it's it's a fairly simple project, but it does involve enough both software and hardware that it's kind of interesting, an interesting sort of problem to solve, and something like most people could manage to do. Anyway, any other questions? Or?
Your tires are on the front, right?
Well, they're actually on the back, and part of the idea
In the video, it was running back.
Yeah, it was running backwards in the video. Yeah, no,
It just strikes me that the other guy's robot had sort of a slanted front, which a few of them.
Yeah. The tire goes straight. That's exactly why. The idea I've got is I put the weight in the front and some rollers, and the idea is when it hits the other robot, if it pushes up, all it'll do is put more weight on the tires at my back. Because it's obviously, if you look at some of them, they do have scoops, and if you have your wheels in a position where they can get lose traction, then it's all over.
You only have 2 driven wheels?
You can have as many wheels as you like, but it has to fit inside the size. And if you have smaller wheels, then you have to have much smaller wheels. So it's going to do. I looked at the size with these, and I could have smaller wheels. That's about the maximum size you could have. These fit end on end for about 10 centimeters. So, but yeah, I mean, you can do all sorts of things. You could do tank tracks if you really wanted to, but whether you're going to get more traction, whether it's going to work better or not, I don't know. and speed and other things. Yeah, it's.
Do you have to have wheels at all?
I don't know that there's any rule about having to have wheels.
So if I just have like a ½ kilogram block, do I win if the other guy accidentally falls off?
Well, if he falls off, but if he doesn't fall off, I think you both lose or something.
Okay.
So yeah, I mean there are actually people who don't try and push the other guy. All they try and do is run around the track as quickly as possible and stay out of the way of the other robot. And if the other robot falls off the track trying to chase it, well, it loses. So, I mean, like in the example, you saw one where it just went zoom straight off the edge. That's all very well if it hits. If it misses, then, you lose straight away. So, yeah. But it's kind of, it's one of the reasons I kind of like the sumo competition, because it's complicated enough that, you can think about lots of different ways of how to solve it, and there's lots of different possibilities, but it's simple enough that, you can actually implement them realistically without wasting heaps of time.
Is it like real sumo that the thing flips over and then?
Well, basically for the one we're doing, they have an IR code, like they've got a remote and they send the IR code, and as soon as your robot receives that, it can start.
So what happens if they're both still on the track, but one of them?
Oh, if it flips over, if one falls over, yeah, it loses. Okay. So yeah, it's not just being pushed out if it falls over. The other one too is if you lose more than, I think it was a couple of grams of weight off your robot. So for example, if your battery pack falls out or something like that, then you lose. So it has to stay as a single thing. The other one that's interesting is you can actually have deployments. So some people have things that are almost vertical and then they drop out and then they run across. It's another way of doing it. But I kind of thought about all of the mechanical sort of ways you could try and game it. But the problem is actually getting them to work reliably. And I figured it's better just go simple design and try and optimize it to make sure it actually works. Anyway, no more questions?
Are you doing it by yourself, or is there a group?
I'm working, we're doing it as part of the advanced robotics course at Hackerspace. We did an initial robots course, which sort of had a robot where it was controlled by a remote control, and you got it to go forward 3 steps and then left 3 steps, and we measured how close it got to the destination. The second, the advanced course is basically building a robot sumo, and we compete at the end of it to see who can do it. So yeah, this one I'm working on with my son. I'm doing most of it, I think. Yeah. Anyway, there's no more questions, I guess. I don't know,
how much time do we have left?
Well, we can keep going if you want to talk, but or we could end now, I guess.
Well, so I was sort of trying to put together a talk on Syncthing, which syncs files between 2 computers, but I could also, I don't know how well that'll work in the minute I just set up. I could also talk about PC board design and manufacturing if you wanted to hear a 10-minute quick talk on that.
I think it'd be interesting to hear this. That sounds totally boring.
Whoa. That's a good idea.
Well, I mean, the other one too is you could do it next month if you want to.
Okay, so we've got time for me to chat about things.
Yeah.
So there was something on Tuesday that you attended, right?
Yeah, that was the same thing.
How many people attended? I was going to go and I'm like, wait, it's 15. Is there any drinks included in that?
No. That's basic. Yeah, I thought so too. But it's really we're kind of working out. Basically, it's to support the hackerspace itself because they're paying rent on that. Right. So
I think that's better than meeting. Some of these places they try to meet at bars and things. We're not into that. That gets more expensive.
Right. Yeah. So, well, you should just comment about it to the organizer of the event. All right. So how many people wanted to hear about PC board design?
1.
Why? 2? And Syncthing?
Syncthing, man.
Oh, okay, I guess it's Syncthing then. All right.
Does everybody know what it is? I mean, I've heard about it because it was like, what is it, BitTorrent Sync? People realized that it wasn't open source and they said, oh, we're gonna do it. So that Syncthing kind of came on the scene. I'd be interested in how they're different.
All right, so hey, you would know, what's the XRNR command to mirror the my thing to the VGA?
The exams.
Jim Titz, are you going to give out, auction anything off, or
Ah.
did that happen already?
So first you just type it down that you already have.
Yeah.
Shall I quickly type it? Maybe
Sure.
There's an awful lot of laptop
Oh,
stickers
actually, it's
over
probably
here.
easier
If
if I
your
type it, that's
laptop
fine.
is naked,
Yeah.
please.
Okay, so what do I give it next?
Double hyphen outputs.
If it is type it, it'll give you that.
And VGA1 and double hyphen mode.
Mhm.
And the resolution, so probably 1080p.
I guess 1440 by just wanted to mirror this screen. Do I need to give it a mode if I'm in mirror mode?
I'm not sure if you do, but what yours to do. And then double hyphen same, hyphen without space S.
Ah, same as.
Yeah, and then
LDS1.
And then it takes
You gotta take my picture for on Twitter.
Is
All
that
right? No,
actually?
he likes that.
Oh, yes, there we go.
Sticker.
Sweet. It's about, yes.
Yeah.
Okay, and let's see if my battery's gonna survive this.
Sharp.
Ah,
Is that
There's a
from?
whole bunch of
What's
different
the
kinds.
sharp?
Do I can get either of these? There's two, there's one Zuki and there's one digital.
There's so many projects. Oh, here's a little card. Is this
probably an option.
It's not a category 6 LTE module, is it? No, I don't think, okay. If anybody, I built my own like LTE router, which is pretty cool. But the modules, are, you know.
Oh, what's that? Is that the auction?
I think
he's ready to go.
Oh, he's ready to auction?
Mhm.
Yep. Oh.
Okay, so I'm Curt Sampson, as you heard earlier, and I'm going to talk for a few minutes about Syncthing. Syncthing is basically an application that will sync folders in some sort of moderately secure way between various machines. And it's kind of talked about as a replacement for Dropbox or Google Drive, but it isn't really exactly, as we'll see later when I do some discussion about it. But there's the site for it, syncthing.net. And one of the nice things about it is it does have Android client and Windows clients and all of it. So you can sync across many different kinds of systems. And they go on blah, 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 secure, private, it's all open source, etc. So let's just move on to actually running them. I have this little script here that will, over on the right-hand side, that will run it in a Docker container. Now there are, oh, the Syncthing project is here on GitHub, in case you need that. So I'll just close these windows as I get through them. So there is a Syncthing, has their own Docker container they send out, or they make available, and you'll notice there are a ton of others. So what I use is actually the one from Linux server, mainly just because the Syncthing Docker container doesn't provide you the ability to, when you take your external directory and map it into the Docker container, tell Syncthing, hey, you should run as this user so you have access to it. So what happens is it runs as user 1001, discovers that I put in my directory owned by user 1234 and can't do the access if I use the regular one. So, right, we set this up. There's some various options for it for the networking and stuff. Basically, you need a config and you need a directory in which to dump all of your synchronized folders. And that directory for the synchronized folders will be the config as well, unless you specify otherwise. In this case, I will start up a whole brand new Syncthing. We'll call this one S1. And it makes the container and starts it up. You'll notice it went and generated its own certificates for this stuff right away and basically built its whole config. So if we look over here under the s1.config directory, which was empty when I started, this now has the certificates and the configuration file and the whole bit for all of that. And it's also running as running a web server for the administration interface, which will be, I did not map any ports here. So basically this container is connected to the bridge with an internal IP address, which will be one of the standard Docker ones that normally assigns probably 172.17.02. And no, it's not. So is it 3? Yes, it is. Okay, so that container started on this address. And now this is what you're going to see after your first Syncthing startup. And it'll give you the list of folders and the device information and remote device. So I'm going to start by, for this particular one, just going to the settings and giving this a better name. I called it S1 in the other window, so I'll call it S1 here. And I'll set my default folder path to MNT because that's where this Docker container has the folders storage that I mounted in. Okay, so there we go. And now what we can do is I can start a second one, which I will call S2. And it goes and does a very similar thing. You'll notice here that it's generated a brand new ID, which I will talk about in a second. So now if I go over here, hopefully it came up on this address. No, so let's nmap 72.17.0.0/24, sorry, SP of course. And we'll see where this thing came out. Looks like it's probably, could be on 3, could be on 4. All right, let's just go poke around. This is S1. Oh yeah, S1 was on 3, so it's got to be on 4. Right, and here's a brand new one with no particular name. So I can go back here, settings again. Oops, sorry, I have to enable cookies here. Yeah, so the device has been given a random name at this point. So let's call this one S2. And again, put my folders under MNT. Save all that. All right, now we're happy. Okay, so for each of these, there is, when you start up a new one, it generates a new key pair for itself and then a certificate that itself signs. And this is basically how it identifies itself. This is a standard X.509 certificate as used by TLS or SSL or whatever, or pretty close to that standard. So if I do a show ID here, it's actually going to give me this identification information. This is essentially an encoding of the public key of this host. So basically, if anybody else says this guy's trying to contact me, you know who it is, right? And we'll see if we look at this guy, he's also got, unfortunately, both start with E, which makes them harder. But so this guy ends with WA6, and this guy ends with AQW.
So would this work with somebody in this audience? Would it start?
Yes, you could start one up right now. The only issue would be that I'm on a bridge network that you probably don't have access to, but it might work. Do you want to try it?
Oh, no, I don't.
Oh, okay. So Syncthing has some protocols for discovery. It can like send packets out on the local LAN and say, hey, are there any other Syncthing guys out there? And it also knows about discovery servers. So you can go out to the internet and it'll say, hey, who do I know on this server? Or tell me about who I know.
So
Yes?
on the local LAN, what is it looking for? Port or something?
I don't know offhand the details.
Okay.
Probably just broadcast packets, or it could
So
be
the answer
maybe
is it's not
broadcast.
going to sync over the internet if it's something internal.
Hmm?
If it's in your LAN, it won't like send you.
This
data
is
over the
only for
internet.
discovering other hosts. It's not for doing actual synchronization. That's a separate step. So basically it needs to know I can contact this host on this IP address and say, hey, can I talk to you? Do you want to share blah, blah, blah? And the LAN discovery and the internet discovery, for which you can use standard servers that Syncthing, the Syncthing project runs, or you could set up your own. All of this is just so I can associate an IP address with a name, which is this name up here on the certificate. And that's just how you start any further communication. Okay, so I'm going to pop over and go back here, close that window, and click on Add Remote Device. And you'll notice it's already showing me nearby devices. And this one with ending AQW is in fact that key. So the two devices, I've already noticed that they're both here on my Ethernet internal to this thing. And so I can just click on that and save. And now the device appears down there with that name is basically the first part of the key. And the same thing can be done here. So I'll add a remote device here. Oh, you can also put in device IDs and have it try to do the discovery. You can actually put in the IP address if you know it so that you don't have to use the dynamic discovery, all that sort of thing. Okay, so, oops, I need to click on that. Okay, and if we go back to this guy, why is it saying they should be talking to each other? They probably will start talking soon. Oh, I should mention you're seeing this relay thing here. In fact, I think what's happened here is they did local discovery. Oh no, they should be able to talk to each other. Yeah, there we go. So they've stopped. There are also options once you've discovered somebody. If you can't contact them directly, you can go through a relay server, which is basically just TCP forwarding. The relay server knows nothing about the communication because you're doing TLS on both ends. So all it can see is the encrypted data stream, but it will let you both connect to this one server and then forward the bytes between you. Okay, so this guy's figured out the remote device it's talking to is actually named S2 because S2 sent its name over. And this guy, the same. So now that the two are talking to each other, we can actually try and share some files. So on S1 here, I'm going to create a new folder by clicking Add Folder. And you can, these IDs can be anything you want. You have to be careful because the IDs are global with anybody you're sharing with. So if you have a folder named foo and you suddenly decide you want to share with that guy over there and he's got a different folder named foo, they will both be considered the same folder. But for the purposes of this demo, I'm just going to call my folder foobar, as I'm going to wipe all this and won't have much in the way of collisions. Right, and you can also have, of course, a local label for it, which doesn't have to be the same on each device. And you can put the path anywhere you want. In this case, I'll put it on MNT foobar, and I'm going to share it with S2. So I save that, and it's scanned it, and it's up to date. And we will notice that if I CD into S1 here, this is the mount directory that's inside the Docker container. And it has created this foobar folder, which it's sharing. And so I can say echo 1 to foo, and now we have a file in there that it will be sharing. You'll notice there's also this ST folder, which contains various synchronization information that it uses to do its synchronization. Right. So going back to S2, we now see that it's received the information that S1's willing to share this folder with it. So I will sure add it, and we'll call it S1's foobar folder, because that name can be different, but I'm just going to stick it under foobar as well here. Right? And so now they will be syncing, and very soon we should see, if we CD into S2's thing, yes, there's the foobar folder there. And for some reason, this is a little bit slower here than I've seen it elsewhere, but we should very soon see it. Oh, there it is. So now we've got the foo file that's been synced. And we could echo 2 to the end of that foo file. And eventually, we will find that it gets actually, this will probably be removed and replaced completely with the other version of the file. But eventually we should see that this foo is updated. And that's basically how it works. So it syncs on the basis of what they call folders, which I would actually think of more as volumes. It's basically one entire directory tree. And you can't do synchronizations of subportions of that tree. So it's quite different from synchronization systems such as Dropbox or whatever, Google Drive or whatever else. In that those ones, they imagine you're going to have your whole everything, your terabyte of stuff sitting on the Dropbox server. And then when you hook up a new machine, you say, okay, I just want to sync these subdirs, and you can change it for every machine. This system doesn't do that. I would have to go, and rather than just have a media subfolder and a backup subfolder. In fact, in my Dropbox, I've got one folder called B, which contains all the huge stuff. So there's backup subfolders, scans of all my books, etc. And the first thing I do when I sync Dropbox with one of these systems is I turn that off so that it doesn't haul down, half a terabyte of crud that I don't normally want. So for this kind of thing, I would actually have to have separate volumes for all of this. I'd have to decide in advance, am I going to want to sync this to a machine? And it's all or nothing, turn that on or off. So that is basically kind of the huge difference. I guess the good part about this is that you can run your own servers and you can basically sync it anywhere. You could just set up, say, one server in AWS and another one in DigitalOcean, and just be using those to sync to both of them. And if one of those dies, well, you don't care, you've still got the other one running. And if you happen to want a full copy at home, you can do that. You could stay completely out of the cloud, just running your own servers if you've got, you don't even need a static IP at home. In fact, you could just be going through, if you're willing to deal with the forwarding and stuff, you can just have it talking to one of the discovery servers and have that both when people come to it and ask, hey, what's the IP address of blah, 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 it would be able to give out whatever your dynamic IP address is. Even there, you can't communicate with it directly, but so long as it's talking to a forwarding server, you talk to the forwarding server and say, please forward my connection to my server at home, and you're set. And the other thing I should mention, two more things, I suppose. Trust is transitive. So basically these things, as you can see, identify each other pretty simply just by those TLS certificates they create. You say, okay, this guy I am going to trust is so-and-so by this particular server name within the TLS certificate. And so nobody should be able to spoof that. But if you're sharing a volume with him, he can basically connect with anybody else and share with anybody else. And when you get back a change from this guy saying, hey, I went and changed this file to blah, you get that from the guy you're talking to directly, but you have no idea if he did it or if it came from somewhere beyond there or what. So this is another big difference from systems like Dropbox. On Dropbox, since it's centralized, if you lose your laptop or whatever, you've got a client you're worried about, you can just go to the Dropbox interface and say, okay, turn off this guy's access, because everybody has their own application key they use to access that Dropbox. Whereas with this one, basically, as far as I can tell, all you can do is essentially delete that volume and create a new one with the same contents.
I have one question.
Yep.
How does it handle conflicts?
Okay. So it handles it basically the same way that Dropbox does, and I'm sure everybody else. Let's take a look at, okay, so we've got foo here has 1, 2, and foo here has 1, 2. So let's echo 3 to the end of foo and echo 4 to the end of foo. And we'll do those very close together. And as it syncs over the course of the next minute or so, you will see it'll create at least one file under a separate name that says conflict speak with blah, 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 or something like that. So basically, it just gives you both copies of the file and adds a little to the name. There we go. So we can see we've got the foo sync conflict there. And in this case, it appears it took foo from S1 and decided, did it? Yes, and then it replicated back here. So what happened is S2 got the new copy of foo and said, okay, S1's is the real one. I'm going to take my version, make this sync conflict file. And at that point, it becomes just another regular file. And so the reason S1 has a copy of that is because it said, oh, there's a file on the other system that I don't have. And if there were conflict in a conflict file, it would just extend the name more. It'd be sync conflict blah, and then that is just another normal file that would get synced as well. And this also has facilities for keeping backups, I should mention. You can keep older copies of files, tell it, keep, for the last hour, keep a version from every minute. For the last week, keep a version from every day, that kind of thing. And that, again, is just straight full copy of the file. And that's on a per client basis. So you can have your server with lots of space keeping months of backups, but you don't have to keep any backups at all on your laptop if you don't want to. Sorry, go ahead.
For example, if you prepare a big file, halfway through syncing, suddenly the connection be cut or you don't. Will it resume from